Hi, I'm Matthew Graham, student number 214320483, and this is my video presentation for SER 202, Programming of Embedded Systems. The design brief for this trimester was to design and construct a standalone animatronic arm. That is, one that didn't need an external power supply or a computer to control it. The ham was to display 5 different American Sign Language characters at 2 different speeds, with all programming to be done in C using an Arduino Mega 2560 as the electronic control unit. The ham was to have a user interface which allowed the user to select the individual character as well as the speed it was displayed. We were also asked to implement our own special feature or X factor as part of the project.
After some quick research, I found that the internet was full of different designs for animatronic arms using many different materials, but as the servos are small, there was a need to keep weight to a minimum, and so decided a timber hand would be best to keep both weight and costs down. For the arm itself, I was able to shape a log from a recently cut down tree. The fingers were made from a 22mm dowel that was part of a broom handle cut into small segments. Holes were then drilled into the segments and they were shaped to allow movement. I did this by chamfering the edges with a battery grinder. As shown, an eyelet was screwed into the back of each segment and the pieces were joined together by threading a thin piece of copper wire through the pre-drilled holes. This then becomes the hinging mechanism for the finger joints. The same method is used to attach the fingers to the hand. The servos and push buttons have been mounted on scrap aluminium and screwed to the arm. This is where the eyelets are used. By running fishing line through the eyelets between the servo arm and the end eyelet, it gives the fingers the movement they require. Gravity pulls the fingers down when the line goes slack, although the thumb needed an elastic band to pull it down. As the servo arms move away, the line pulls the fingers up. To keep the arm tidy, I've bored holes through the timber. All the servo, sensor and LED wires run through the center of the arm into the plastic mounting enclosure, where they attach to the Arduino board and the breadboard. Here the Arduino board can be seen with the orange servo signal wires at the top, or push button wires at the far right. The bottom wires are the 5V ground and the input from the analog sensor. On the breadboard are all the extra connections needed, along with the 220 ohm resistors that are in series with the LEDs, and the 10k ohm resistors I have chosen to use instead of the internal ones, due to issues in the past. A quick look at the code, and at the top we have all the variables and constants we will need throughout the program, including all the integers for the servo movements. Then there are the floats for the analog sensor. Using the serial monitor, I was able to equate voltage readings to real temperatures and have set the minimum temperature at 7 degrees and the maximum at 40 degrees. These temperatures will be used in my X factor. Although used to set up the temperature readings, the serial monitor code was no longer needed and has been deleted. In the setup for the program, I have made pins 2, 3, 5, 6 and 7 output pins for the servos, and pins 32, 34 and 36 output pins for the LEDs. All servo registers have been set up with fast pulse width modulation and a clock setting speed of 256. The 5 servos have been set to run off individual variables, and to begin that, variable has been given a value. Right at the end of the setup, the analog digital converter register has been initialized. Now for the main code. To start with, the reading from the sensor is converted to a usable variable. This variable is compared against the maximum value we defined earlier. If above this value, then part of the X factor code is implemented. Or if below the minimum value, another part of the X factor code is implemented. If between these two values, the fingers stay straight and the center light stays on. Then we have the push button code with if and if-else statements used to see which button is pressed and implement the required configuration of servo positions. Towards the bottom, we have the analog to digital converter initialization, as well as some loops for the slow and fast movement setups of the 5 servos. Now for our push buttons and sign language characters. The first letter is D. It is represented by the index finger up. By pressing push button 1, the action happens quickly. By pressing button 2, you can see the action happens a lot slower. Here is the back view showing the servo movement of these configurations. Next is I. It is the pinky finger raised and all other fingers closed. By pressing push button 3, the action happens quickly, and button 4 makes the action move slowly. Here is the rear view showing the servo movement through this configuration. Then we have L. It is the index and thumb up and all other fingers closed. By pressing button 5, the action happens quickly, and button 6 makes the same configuration but slower. Again, the servo movement can be seen in the rear view. Now we have V, which you may guess is a peace sign or middle finger and index finger up. This movement is done quickly by button 7 and slowly by button 8. Again, the rear view shows the servo movement. The last letter I have chosen is Y, which is represented by the pinky and thumb out and the 3 middle fingers closed. Buttons 9 and 10 control this movement, with button 9 doing the fast movement and 10 doing the slow. Again, the rear servo movement can be seen. Now to my X factor. As explained earlier, I'm using a temperature sensor, and it has been set up with a high and low value points. Now we can see what happens if it goes below its bottom point of 7 degrees. To do this, I've placed the arm inside an industrial cool room. As it takes a little while to adjust to the temperature, the green light remains on. After a short wait, the green light has turned off and the blue light has come on, and the fingers have begun drumming. Here the servo movement can be seen. As it warms up, the blue light turns off, the green light comes on. Now, let's apply some heat. Using a heat gun, it can be seen that when the voltage reading reached the set point, which relates to 40 degrees, the red light has come on and the fingers began to open and close. As it cools to below 40 degrees, the movement stops and the green light comes on. This concludes our demonstration for today. Thank you for your time.